now we're going to continue on with some practice. This next one's actually pretty quick. They give us the equation of a circle. You can pull from the equation that the center is 37, comma negative 13. Remember, it's opposite of what you think because it's minus the coordinate. So minus the 37 and minus the negative 13 will make that plus. The other clue that they're giving us is that this is your radius squared, which means your radius is 4, because 4 squared equals 16. Now, what they actually asked us for is the area. And if we think back to our area formulas from our last chapter, the area of a circle is pi times radius squared. So really all you need to know is that it's pi times your radius of 4 squared, which is the same as 16 times pi. Notice I'm writing the 16 as a coefficient in front. So if you were creative, you actually don't need to do anything but pull that 16 from the equation. So that's a really nice way to connect our current topic with our last topic. This next one, part C, is also a little bit interesting, and it connects to some of our older concepts that we've seen before. So this one has a point that's on a circle with the center at negative 1, 5. So if I'm trying to get a picture, I know the center is left 1, up 1, 2, 3, 4, 5. So let's say I know that's the center. And then it has some sort of a radius, right? This point, negative 6, so 1, 2, 3, 4, 5, 6, and up 17, so like way up here, is also on this circle, which means if I'm trying to kind of envision my circle, I could figure out what my radius is by figuring out how far apart your 2 points are. So you kind of want to find that distance, right? Now, the really cool thing that connects to some of our old topics is we can use a right triangle and do Pythagorean theorem. You also could use your distance formula, but remember, just a key thing, distance formula is the same as Pythagorean theorem. It just goes at it from a little bit of a different way. So distance formula is a little bit more algebraic in how it's built out. Pythagorean theorem is the same thing, just a little bit more boiled down. So if I want to get my different side lengths, right, I know that this is at a height of 17. So my y difference goes from a height of 17 all the way down. The other one is only at a height of 5. So how much difference in height has gone on between 5 and 17? That will be a 12. And then you also want to figure out your distances in x. So x started at a negative 1, got all the way to a negative 6. So how far is it from negative 1 to negative 6 in steps? It would only be 5 steps. Okay, so from here we want to find our radius. So this is going to represent radius. So I know 12 squared plus 5 squared has to equal radius squared. 12 squared is 144, 5 squared is 25, equals radius squared. We now have 169 equals radius squared, and I know that r would be the square root of 169, which should come out on your calculator to 13. Now, we're almost home free. The one thing we have to do is write it all out as a formula of a circle. So I'm kind of putting in my shell, x minus the x coordinate squared plus y minus y coordinate squared equals radius squared. I have just figured out that my radius is 13. Okay, and the center of my circle is given as negative 1, 5. So x minus negative 1, y minus 5. If you want to write it out formally, it would be plus 1 squared plus y minus 5 squared equals 169. So what's kind of interesting is you actually don't need to figure out that the radius is 13, because the only part you really need in the equation you can simplify to radius squared and just leave it as 169. So I'm going to continue with some more of these problems. At this point, you are finished with your lesson. You do not have to continue listening, only stay on if you are curious with some of the other challenge problems. Okay, so this is not required at all. Okay, so this one asks us to write an equation of a line that is tangent, which means it's making a right angle, and it's only going to be touching the circle at one point. Touch at one point. Remember, if a line is tangent to a circle, so here's the one point, and the right angle comes with the radius. So it's perpendicular to a radius that's drawn to that tangent line is how you can think of it. The biggest thing is just touching at one point though. So that one point here. Okay, so we want an equation of a line tangent to a circle that passes through -6, 17. Okay. So I believe that this is still part of problem C. So we have just found, yes, that makes more sense. So we're still part of the same circle that we were just discussing. So here's the circle's equation that we figured out in part 1. Okay. 69, we know radius is 13, center is -1, 5, and we want to find the equation of a line tangent to the circle passing through that specific point that they highlighted before to -6, 17. So actually I'm going to keep that picture there. So we're going to assume that this is -6, 17. Okay. So the biggest thing here is we want to figure out the slope. If we figure out the slope of this line, remember, if you want them to be perpendicular, we're going to use that slope and do the opposite reciprocal slope. So the slope of the radius there would go from the center, which is -1, 5, and it would go through -6, 17. So we're going to find that slope, and then we're going to do the opposite reciprocal will be our next step. Okay, I'm going to erase some of our clues just because we have them up above on the sheet. Okay, so my slope would be y2 minus y1 over x2 minus x1. I'm just going to label them as such. You can do it whichever one you want can be first coordinate, whichever one you want can be second coordinate, as long as you are consistent. Okay, so there's my slope. Now I want to do the opposite reciprocal slope, which is opposite would be plus, reciprocal would flip that. Okay, and I'm just double checking that all my work looks good, that I did 17 minus 5, -6 minus the -1, that all looks good. So now from here, I know that this is the slope that I want to use, right? And I know I need to go through the point of -6, 17. Now here is where we get to a point where there's two different ways you can go about this. If you remember point slope form, which is y minus y1 equals m times x minus x1. And remember, point slope form is really just taking slope. Remember, slope is y2 minus y1. It's kind of that same idea, and it's treating it as if you were solving for the y piece and multiplied both sides by x2 minus x1 to see how that matches up here. So it's really just rearranging the slope formula, and it's called point slope form. So if I plug that in, y minus the y coordinate of my point is 17 equals slope of 5 over 12 times x minus my x coordinate there was -6, so that's going to become +6. So that's one option for solving for your equation. The other option, if you do not like point slope, you could do slope intercept form, which is mx plus b, and you would say, okay, I know the slope is 5/12. And then in order to solve, you don't have enough information because you don't have the y-intercept. You would have to plug in your point, you'd have to plug in your point, which has a y-coordinate of 17 and an x-coordinate of -6. And then you would have to solve for your b. And then from there, you would have to write it out formally. So I'm just going to write it 5/12x plus. I'm going to do the solving real quick on my calculator. So if I do 5 divided by 12 times -6, and then if I do 17 divided by that answer, looks like B is about -6.8. Okay, so there are two different ways you can write your equation, depending on which way comes more naturally to you. You have one more question left, and this one is also an interesting challenge problem. This one gives us a circle that has a diameter with endpoints of -5, 8 and -11, 0, and we need to find the equation of the circle. So if we kind of think through what we're given, I'm just going to draw a circle. So here is maybe my diameter. We need to find the equation of the circle. So the things that we need to write an equation of a circle are a center and a radius, right? So I could figure out my center by doing the middle, right? So I'm going to do midpoint formula, which is something we did in semester 1 to find my center. So I'm going to change this so I can kind of color code my work. So my orange work will be for my center. And your midpoint formula is x1 plus x2. Add your x's together and cut them in half. y1 plus y2 divide by 2. And all it's really doing is averaging your x's and averaging your y's to find what's in the middle of the two. Okay, so if I plug in what I've got, it looks like I'm going to have -16 cut in half and then 8 cut in half. So it looks like my midpoint or my center is -8, 4. And if you think through it, that makes sense. Like 4 is the y-coordinate that does land in the middle of 8 and 0. Same thing happening with -8, that would be in the middle of -5 and -11. Okay, so I'm just finding the middle. My radius work is going to be a little bit more interesting. So for this one, it might actually help to have a more accurate sketch to help you think through this one. So I have -5, 8, and -11, 0. So it looks something like this. So if I want to figure out what my radius is, I now have my center, which is -8, 4, right? If I want my radius, it's this distance from the center to that point, -11, 0. I'm going to draw it in as a right triangle because I'm going to be using Pythagorean theorem. Okay. So I've got my right triangle. Now I want you to think about your center is how tall. Our center is 4 tall. And I went from a height of 0. So for my right triangle, I've gone 4 up in the y direction. So that's going to be my label for the height. My x has gone from, let's see, we have a coordinate for the center at -8. And then this is -11. So the difference between -8 and -11, if I just kind of did it like steps, that's 3 steps over. So if I do 3 squared plus 4 squared equals r squared, because that's like your radius, right? I'm going to get 9 plus 16 equals radius squared, which tells me my radius is 5. Okay, so from here, if I want my equation, remember you've got x minus x coordinate squared plus y minus the y coordinate squared equals radius squared. So if you plug that in, you're going to get x minus -8, which is going to become a +8. Right, if I plug in my -8, and then you've got 4 for the y, that's pretty straightforward, y minus 4 squared equals, and your radius squared is going to be 5 squared, or 25. Okay, so there's your final answer. If you stuck around to try out some of those more difficult challenge or honors level problems, thank you for sticking around and stretching your brain a little bit with me. I will see you guys in the next video. Have a good day.